Myself, Aniket Sharma. The topic is to be covered here is impact of jet. There are basically 3 points related to this. First, we have to calculate the force exerted by the liquid on stationary vertical and guide vertical plate. Second one is a force exerted by the liquid jet on a stationary curved vane. And third one is a liquid jet on a hinge plate. So, what is impact of jet here? The question arises. So, impact of jet is nothing. Basically, a liquid coming out from a pipe and being nozzle fitted on a end of the pipe here, which have increase in the velocity and the liquid coming out from the nozzle in the form of jet here. So there are the first case here, the force exerted on a stationary vertical plate here. If I am talking about the conceptual thing here, that is the momentum. How momentum is transferred by a liquid jet after striking to the plate. Here the plate is a stationary vertical flat plate. The jet deflects the 90-degree tangential after the striking to the plate. We assume here there is a no friction and no energy loss on impact. The force exerted on the stationary vertical plate having the same velocity after striking, that is V1 equal to V2. The thing here we have to calculate, that is the mass flow rate of the liquid striking the plate, is given below. This is the mass flow rate here. We have to calculate that it is equal to the rho AV, that is the change in momentum here. So if we have to calculate the force in the x direction, we have to use the impulse momentum equation here, that is change into momentum into velocity. So change in momentum we will calculate from that is the initial momentum and the final momentum. So we know that after striking to the flat plate, the velocity becomes 0. So the final moment here is equal to the 0. So the rate of change of momentum here, rho AV, in a bracket V minus 0 upon time, that is equal to the rho AV square, which is equated to the force exerted in the x direction on a stationary vertical flat plate. The points to be remembered here, that we have using the Newton's third law of motion here. Next topic here is the force exerted on the stationary inclined flat plate. In this inclination of the plate with respect to the horizontal, there is an angle theta here from which the liquid jet deflects to the direction with the velocity V, capital V, and having the different value of the discharge here, Q1 and Q2. So the mass flow rate liquid striking after the plate is calculated with the same concept as in the previous case, that is rho AV. But the component of the velocity normal to the plate is having the angle of 90 minus theta here. So we have the resolution of the angle in a horizontal direction, that is cos theta, and vertical direction is sin theta. Because angle is 90 minus theta, so cos theta will converge to the cos 90 minus theta, that is sin theta. So the velocity here is V sin theta. And normal to the jet leave tangentially, we know that. So the final velocity in the direction normal to the plate will be the 0. Next, we have to calculate the Fn, that is a normal force here, that is rho AV, V minus sin theta minus 0, that is equal to the rho AV square sin theta. As we have a two component here, so we have to calculate the two forces, that is Fx and Fy, rho AV square sin square theta and rho AV sin theta and cos theta. Here we have to use the impulse momentum equation, that is Fs is equal to the total net forces, that is related to the rho QV cos theta minus rho Q1V plus rho Q2V. This rho QV cos theta is related to the total impulse after striking, and this rho q v1 minus rho q v2 is equal to the total impulse after the before the striking. So here we have got the equation, that is q cos theta minus q1 plus q2 equal to 0. So capital Q is equal to q1 plus q2 here. So we get the formula here q1 and q2 in the form of theta and capital Q, that is the discharge here. This is the sample question here, you have to try with the formula given. Jet is striking a symmetrical curved vein at the center. So as discussed here, this is the curved vein here having the velocity v, but you can see here that this is the component v cos theta in the negative x direction. So for calculating this, the component of velocity of jet striking in the vein in the direction of jet is minus v cos theta, and in the direction of jet after the striking in the direction of jet is v sin theta. So fx is here, that is rho a v square 1 plus cos theta, and fy is rho a v square sin theta. So the last function here is jet striking a symmetrical vein, curved vein tangentially at one top. It is a similar case having the previous concept. So we have to calculate here fx with the same concept after resolving the forces at the curved section after striking of the jet. So jet is striking in a symmetrical curved vein tangentially at the one tip. It is also a similar case. So here is a case that is a jet striking a hinge flat plate. So we have to calculate the force here. The force Fn is equal to rho a v square sine 90 minus theta here, that is the force normal to the jet of the plate, and we have to calculate the weight of the plate which is hinged at the one point O. After equating the moment, we get the equation of the sine theta, that is rho a v square upon W. So here is all with the concept of the impact of jet here. For any queries, please contact me.